if an initial layout for a graph is given, such as this one skeleton of the Venus de Milo here, our multigrid scheme can solve the system setting each vertex's Laplacian not to 0, but rather to what it was in the original layout. That way, when you click and drag vertices, it distorts the graph while sort of preserving details. We found that this technique is good for sort of pulling apart tangled portions of the layout and exposing details in the graph that you might not otherwise see. For this demo, we've given the graph a random initial layout, and this is a different technique that also uses some ideas from 3D modeling. Here the user can click and drag vertices, and there's no longer a notion of a fixed point. Instead, every vertex in the graph follows the clicked point, but vertices that are nearer to the click point in the graph metric follow it more. So this technique is very inexpensive. All it requires is a breadth-first search on the mouse down event, and then subsequent iterations just do linear interpolation. We've added a couple more utility features to this program. The user can randomly perturb the vertices, which sometimes shows some information. You can do an iteration of Gauss-Seidel smoothing, which can help a lot. And the user can control the range of influence of the clicked point. So we can make that really small and just edit part of the graph here. Despite the simplicity of the technique, it can actually be used to produce some surprisingly informative layouts. This particular graph is kind of a humorous example because when we downloaded it, we didn't know what it was, and then after tinkering with it with this program for a while, we figured out that it's a map of the United Kingdom. You can kind of see here's Scotland, here would be Wales or something. It's in mirror image. Here's Cornwall down here. Here's our interpolation technique again, this time on a bigger graph. This one has about 60,000 vertices and about 90,000 edges. So we can pull that one out, and after a few pulls, some of the topology of the graph starts to become apparent. We can do a smooth or two. And now you can see that the graph is kind of planar by reducing the radius of influence, and we can do some more local editing to kind of pull out some of these parts down here. And after you've done that a while, a few more smooths usually help a little bit. Those last two graphs were planar. Here's another graph with about 22,000 nodes and 40,000 edges. But it's not as nice because it isn't planar, but our software can still give you a pretty good idea as to the nature of the graph. Here it is after a few pulls. This one helps to pull into the third dimension, so we'll do that a little bit. And then a couple of smooths.